In this lecture, we will keep working on the mathematical induction. And here is the example. Prove that the statement is true for every positive integer. The statement is 3 is a factor of n cubed minus n plus 3. How to do that? If we want to prove this is true for every positive integer, we may start with n equals 1. If n is 1, you plug 1 into this expression, so you have 1 cubed minus 1 plus 3. Okay, replace n with 1. And then that's 1 minus 1 plus 3, and then that's 3. And then 3, of course, is a factor of this one. Okay, so you may say, then the statement is true for n equals 1. Now you may say, assume the statement is true for n equals k. Okay. Then k at least can be 1. So you have a base. From here you can start. Okay, so the first step is really necessary. Okay. Yeah. And then this tells us what? If 3 is a factor for this expression, when this expression is true for k, then basically you may write, then the expression k cubed minus k plus 3 is divisible by 3. Assume the statement is true for n equals k. Means this. 3 divides this expression. Okay, or this expression is divisible by 3. So you may write in this way. Okay. Now, what is our goal again? You want to prove from here, this is the starting point. Our goal is to prove three is a factor of k plus 1 cubed minus k plus 1 plus 3. That's our goal. You assume this is true. You assume this is true. You want to prove that. Okay. So, how we are going to handle that? Then you got to use this condition anyway. Now let's see how does it look like. Okay. So we have a k plus 1 cubed minus k plus 1 plus 3. We want to show that there is a factor 3 right here. Okay. So you want to FOIL this 3 cubed. You want it no, k plus 1 cubed is k plus 1 k plus 1 k plus 1. If you remember the formula, and then you can quickly write it out. If you don't remember, you better do is FOIL these two, and then by using distributive property to find out the final answer. Okay, I remember that, so save my time. That's k cubed plus 3k squared plus 3k plus 1. That's from the first part. Okay, and then minus k plus 1, I know that's minus k minus 1 plus 3. Okay, now what we can do is I can cancel something right here. And we mark it. First, you do the cancellation. Okay, there are some techniques right here. You may cancel that with that, and then you may add those two together. Okay, then you may do something more. Now let me write k cubed plus 3k squared. 3k minus k is actually minus 1k. So then you get is 2k. Plus minus cancel. So you have a 3. Okay, now you're going to use this one. That's the deal. How to use this one? Because we assume this is true, we have to use it. Here it has k cubed. Here it has 3. We have a k cubed and a 3 here. We don't have a minus k. But you know, what we can do is right here is if you minus k, and you have to do plus k. Okay? And then look, if you put all those 3 together, you see k cubed minus k plus 3 comes out. Okay? So let's see where I should write that. Let me write here. K cubed, okay, minus k. Let me put 3 behind it. Okay. Now here it has 3k squared, so I put it 3k squared. And here k, 2k, together is 3k. Okay, you see. And then this one would be the same. Fair enough, this one is divisible by 3 because we assume this is true. That's the technique. How about this one? This one for sure is divisible by 3 because you see 3 times k squared plus 3k. Okay, this one is divisible, this one is divisible. Then you may say, or you may write one more step. You may write one more step. Put parentheses here. You pull 3 out. Okay. Then you may write, okay, 3 divides k cubed minus k plus 3. As we assume this is true. Okay, so you have to use this one. And 3 divides 3k squared plus 1, plus k right here. So then this gives us what? So this then gives us 3 divides the sum. Okay, so then this gives us 3 divides the whole thing, and then the whole thing equals above here. So 3 then divides k plus 1 cubed minus k plus 1 minus 3. Okay. So then we have proved 3 is a factor for this one. Okay. Now you may conclude then the statement is true for n equals k plus 1. Okay. And then we may say, okay, hence k3 is a factor of n cubed minus n plus 3 plus 3 for every natural number. Every natural number. Okay. So start with n equals 1 and assume it is true for k. Then up to here you have proved the statement is true for n equals k plus 1. Then you can conclude 3 is a factor of this one for every natural number. Okay? The reason, again, is because of what? We have a base, and k can choose 1. If k is 1, k plus 1 is 2. So the statement is true then for n equals 2. And then go through this loop again. K can be true. This statement can be true for k choose 2. And the same process, the proof process applies. So then the statement is true for n equals 3. Okay, because it's true for 2, you add 1 would be true for 3. Then you go back, it's true for 3, it will be true for 4. Okay, so this loop applies. Then you can then say, oh, okay, It is true for every positive integer.